Good morning, everyone who's joined so far. We'll just give it a couple of minutes for some more people to join the webinar and we'll get started. Hi, everyone. We're just going to wait one more minute for some more people to arrive and then we'll kick off the webinar today. Thank you, everyone who's joined so far. We're just going to wait one more minute for some more people to arrive and we'll get going. Okay, good morning, everybody. We're a couple of minutes past 11, so I'll start things off. Firstly, thank you very much for joining the HDR UK June Data Access and Discovery webinar. Our theme today is on reproducibility in health data science. My name is Rosie Wakeham. I'm Head of Training at HDR UK, and we're very fortunate today to be joined by a couple of speakers. We have Heidi Seibold, who is an open data science trainer with a passion for reproducibility. Heidi's going to be speaking to us today about reproducible data analysis and reproducible analytical pipelines and their importance. And Ruth Milne is our Gateway Digital Content and Community Lead at HDR UK. And Ruth will be providing updates to the Gateway along with some developmental highlights. A couple of housekeeping things before we get going. The webinar is being recorded and slides will be made available afterwards. We will put the recording on HDR UK Features and our YouTube channel as well, so you'll be able to watch it back. Please do submit questions. We'd love to hear from you. Do drop them into the Q&A function rather than the chat. We'll try to address all of the questions, but if we can't, we'll make sure that we follow up with a document with any questions that we couldn't get to. And there's going to be a survey at the end, which will come up in your browser, and we'd really appreciate your feedback, so keep an eye out for that. So I'm just going to share my screen and we'll kick off with the first of our talks, which is from Ruth.
Good morning, everybody.
Sorry, there we go.
That's all right, no, don't worry.
Thanks, Ruth.
We can probably skip that slide.
Yeah.
There's our house rules as well, very quickly, just to go over our house rules for the webinar. Essentially, please be nice, everybody. Okay, we can skip on to the next one. And there's our agenda as well. So just quickly, thank you, Rosie, for introducing today's webinar, and welcome everybody. Happy Friday. Before we move on to today's main topic on reproducibility in data science, I'm going to spend a little bit of time giving a brief introduction and update to the health data research innovation gateway. But very quickly to introduce myself, I'm Ruth. I'm part of the gateway team here at HDR UK, and my role in a nutshell is really to help the gateway team grow and develop the platform to make sure that it's meeting the needs of all its users, really. And essentially, I get to work with and engage with lots of internal and external stakeholders to share what we're doing, receive and listen to feedback, provide support, and really make sure that what we're doing is serving its purpose. I'm going to begin with a short video introduction to the Gateway, which nicely summarises the reasons why we established the Gateway. And it's really nice for anyone that's new to the Innovation Gateway, and it's also acts as quite a nice refresher for everyone else as well. So if we can go on to the next slide and click play, it should just start playing automatically, fingers crossed. Oh, is there no sound? Oh no, okay, it doesn't look like we have any sound. I can find, give me 2 seconds. No sound, okay, thank you. Maybe we can.
Sorry, Ruth, I'm not sure, was the video not working there?
So there's no sound with the video and it's playing.
Right.
So everyone can hear me, but they can't hear the video. I'm just going to get the video on YouTube and share my screen, and hopefully that'll work. If it doesn't, then we can abandon the video. So
apologies, everyone.
No, it's okay. Give me a couple of.
Sure.
I'm not sure why the sound isn't working. I'm just going to share my screen to play a video from a different source, just to let you know. Okay. No.
Yeah, no sound still.
Can we hear audio?
No.
No, okay.
So I think we need to change our settings in Zoom. Select share sound at the bottom left-hand corner of the share selection.
I don't think we can hear audio again, can we? No. Should we just go back to the presentation, if that's okay? I'll share the link to the video. I'm sorry, everyone. I'm not sure why the audio isn't working. I'll make sure to share the link to that. Okay. It's working for some and not for others. Never mind. I'll share the link to the video and you can watch it after the webinar, not to worry. So basically, it's a summary video of why we established the Gateway, and the Gateway it's basically a common edge point to facilitate the discovery and access to health data sets in the UK. We launched the Gateway in early 2020, and we very recently celebrated our 2-year anniversary. So you can see our progress and some of our key milestones in the timeline graphic that's up on the screen right now. I appreciate that there's quite a lot to see in this graphic, but we have a really fabulous interactive version of this on the Gateway landing page on the HDR UK website. I do provide a link to this later, but we can pop it in the chat as well if you want to go away and have a look at it. It links through to all of the different key milestones, so you can find out lots more information about each one that's listed there. But what I want to do here is just focus on a couple of things to highlight. So firstly, if we have a look at the numbers on the right hand side, it just nicely shows our growth over the last couple of years. So we're at over 202,000 registered users now. 750 plus data sets are listed on the Gateway now, and we've had over 500 data set requests come through via the Gateway. This is by no means an exhaustive list of the stats about the Gateway. You can see a wider collection of metrics on the Gateway dashboard by visiting the Gateway website. Secondly, I just want to point out a couple of recent development pieces of work that have been completed recently. The first is our data use register, which was a big piece of work completed earlier this year. It's a new feature, and it means that data custodians can publicly show how their data sets listed on the Gateway are being used, who's using them, and for what purpose. The register is now live, so you are very welcome to go and search it. We have over 800 data users registered there now, and something that I really like about it is that each data use includes a lay summary, so non-specialists or members of the public can perhaps more easily understand the aims of a research project and why that particular data set is required for that piece of work. I should also mention that the development of the Gateway Data Use Register is part of an ongoing project, and this is led by the UK Health Data Research Alliance, and they're basically developing a core set of standards on data use registries in general, with the aim of improving transparency and in the use of health data for research and innovation. So that was a really big piece of work for us earlier this year. I do encourage everyone to go and have a look at it and let us know what you think. So next, a couple of really recent things that the team have been working on. First is the search functionality on the Gateway. We recently improved the text search behavior where you enter terms into the search box on the homepage. And we shifted the code from or to and, so it means that when you're searching using multiple terms, the search results are much more accurate than they used to be, so give that a try as well. And another stage of our search improvement is working to enhance the user interface of the search results page. So what you see once you've typed your search terms and pressed search, and the list of data sets and other resources that come up as a result of those search terms. Some of the things that we're specifically working on with that is the keyword and the filter and refinement of the keywords and the filtering sections, making our advanced search options a bit clearer and simpler to use. We're also looking to improve the sort and save feature of the search results page. And also we want to improve the general sort of look and feel of the search results page, so that it's just easier to interpret and to find what you're looking for.
Are we supposed to see a new slide now rather than the news and updates, because people are still seeing news and updates?
We should still be looking at the timeline slide.
Okay.
Yeah. Don't worry. I'll let Rosie know when to flick the slide over.
Okay, because people are wondering in the chat if that's still the right slide.
Oh gosh. Oh, I'm so sorry. I've not been keeping an eye on the chat myself. We're still on the same slide. It's okay. You can see everything that I'm talking about on this slide, but I'll indicate to Rosie when to switch it on to the next one. I know I've been talking a lot about with this slide up, but don't worry, we're still supposed to be on this one. But just I've got one more thing to say and then we'll move on to the next slide. So the final thing I just want to point out is our recent work on federated metadata automation. So this is on the bottom half of the timeline slide that's up there on 2022. So we've just released this feature really recently, and essentially it means that data custodians now have the option to sync their metadata catalog directly with Gateway, so that data descriptions about the data sets are automatically pulled through when the custodian is onboarding their data sets to the Gateway. So it means that adding data sets is now a bit faster, slightly less manual, and also any changes that happen to the custodian's catalogue are automatically updated into the Gateway. So it means that anyone searching on the Gateway for a particular data set always has the most up-to-date information about the data sets that they're potentially searching for. And we hope that the work on federated metadata will help us quickly scale the number of data sets that we can list on the Gateway, and also we hope that it's beneficial to the wider ecosystem, and it can form the basis of developing other more sophisticated tools as well. Okay, so now we can flip to the next slide. Thank you. So a couple of things I just want to highlight before we move on to reproducibility. We've got quite a busy June coming up in terms of where we'll be, the Gateway team. And we're attending a number of conferences. So I'm actually going to present at the International Workshop on Science Gateways next week. So I'm going to be talking about some of our recent developments, some of which I've briefly gone through today, as well as some of the lessons learned over the past couple of years when it comes to developing a scientific gateway for health research. Our interim Chief Technology Officer Sushil Verma is going to present at International Data Week. That's being held in Seoul, but he's actually presenting virtually, and he's going to be talking about more broadly about HDR UK's work on trusted research environments. His talk is at a silly time of 2 o'clock in the morning, so it may be one that if you're interested that you watch back rather than watch live. And then finally, the Gateway team will of course be present at our upcoming showcase event for the Digital Innovation Hub programme, which is taking place in Birmingham at the end of this month. So if you are also attending that, you can come and meet some of the Gateway team, ask us questions and find out more about the platform there as well. So I've just got one more slide, if we can move on to the next one before I hand over to Heidi. It's just a few useful links. Again, these will all be shared after the event as well, and we can put some of them in the chat. So the first one, the Gateway homepage, I recommend subscribing to our monthly newsletter to stay updated with development updates, latest data sets, events, anything to do with the Gateway. That's a good way to keep up to date. The timeline that we had on the screen for lots of time, and I've mentioned there's an interactive version that we have, and that's the link to the Gateway landing page, where you can scroll through all the different sections of the timeline and link out to all the different features and functionalities that we highlight there. We also have a few did you know curiosities and facts about the Gateway, which we organised as part of our 2-year celebratory week. We asked some members of our staff to share their facts and sort of did you know bites about the Gateway. So there's some interesting things there to have a read. We also launched a survey as part of our 2nd anniversary celebrations. So if you'd like to share your thoughts about the Gateway, if you've used it before, or if you want to go and have a look and then share your feedback, that would be super helpful. And there's a link there. We do really appreciate any feedback that we get, because it really helps us improve the Gateway experience for everyone using it. So that would be wonderful if you could help us out with that. And then we also have the bottom link there. Again, these will all be shared after the webinar. A link to our other data access and discovery webinars on our community platform. And I think I've gone slightly over my time, so I'm going to stop now and find a link to the video for people to watch in their spare time. We're going to hand over to Heidi now. So thanks very much for listening, everybody.
Thank you so much. And let me just share my screen. Here we go. Can you see my slides? Okay, excellent. So I'm going to be talking about reproducible data analysis and in particular, what it means also in health research. My name is Heidi Seibold. I'm an open science trainer, consultant, and conference moderator, and you can find me on Twitter under @HeidiBaya. Of course, my slides are openly licensed, and as Rosie said before, you will receive all of the slides from the session as well. Okay, what am I gonna be talking about? What does reproducible data analysis mean? So in health research, we collect a lot of data, and then what we do is we wanna learn something from the data. And so we run some data analysis, we do data cleaning, we create summary statistics, we run machine learning algorithms, whatever it may be. And we can imagine something like a pipeline, right? So data comes in at some points, and then the pipeline that you see here on the bottom left is how we imagine the code to be. So the pipeline itself is based on code, data analysis code, data preparation code, whatever it may be. And so what do we actually need for such a reproducible data analysis pipeline? And I think the 3 most important parts for this is, first of all, using code instead of using clicking programs such as SPSS or programs like Excel. Using code is just, I guess, obligatory for making it really a reproducible pipeline. Then the second thing is documenting the different steps. So how does the pipeline fit together, the different blocks of the pipeline, or even automating the glue that makes the pipeline fit together. And then the third point, it might seem obvious, but with increasingly complex projects and increasingly bigger research teams, staying organized is actually not so easy anymore. And files and folders are flying around on computers, and emails are being sent with files, and it's getting increasingly complex to keep your data analysis projects or your research projects in general organized. And one thing that's not obligatory that I wanted to mention, but to me, it was one of the most helpful bits of making my work more reproducible, is using version control. And I'm gonna talk about all these points in a bit in more detail. So as I said before, such a reproducible data analysis pipeline consists of different blocks where we create or write code that does data cleaning, overview of the data, such as summary statistics, figures, some modeling, so machine learning algorithms, statistical models, what have you. You might also want to include text, so create a report or even a paper. So this text part is obviously not always part of a reproducible analysis pipeline, but oftentimes I would say what comes out in the end is a report or a paper or something that people can read and work with from there. So this looks very simple, but in reality, what we have is rather something much more complex. We have circles in there. We have much more different types of data, sometimes coming in at different points of the analysis pipeline. So most research projects rather look something like this, rather than what I showed before on the previous slide. And that, of course, makes it much more difficult to actually create something that's really reproducible and reusable for others as well. So what we would like to have in the perfect world, right? If we were to make wishes and come up with ideas like, what would the perfect world look like? And to me, it would look like this. I would have a box and I would put all my parts of my research project into the box. So the data, the code, lab protocols, what have you, all the parts that my research project consists of, and I put them in this neat little box. And then in the end, I push a button and out comes a shiny report, a shiny paper. So like we have in this image here. And this perfect box is usually, of course, a folder on your computer, right? So all the files and codes and data are digital. And so this box that we see here in blue is really a folder on our computer. And what we call this box is a research compendium. And of course, having this button that creates it all automatically in an automatized way, this is really something that's really hard to get. And I want to talk a little bit about how to get closer to having this perfect research compendium in the next few minutes. So how to do that depends a lot on your skill set and your preferred tools. And I'm going to talk a little bit about the kinds of tools that I personally use. So this is a very personal talk for me, because this might be different for you. So if you're a Python user, you might use Python instead of R. If you like Markdown better than LaTeX, then that might be fine, is totally fine as well, of course. And instead of using Make, as I do, you might use other tools. So what are the tools that I'm using? So I'm using, first of all, I use R for data analysis and data preparation as well. So I'm also not doing my data cleaning in Excel, because for me, reproducibility starts with the data, and I can only make it reproducible if I'm using code to do that. Then I'm using LaTeX for writing texts, and I also combine R and LaTeX, which I'm going to talk about in a second, which is then called Knitter, where you can really do literate programming and combine text and code in one file. And then as I said before, we need something to glue the different parts. So the data cleaning, the data summary, the modeling, all the different parts of the pipeline together in some way. And for that, I'm using Make. And I'm going to explain how that works in a bit as well. And then I mentioned before that I use version control to version my files and keep them in the right form and order, and also figure out who did what changes on the code when, which is also a very useful part of Git. And so I'm using Git for version control, which is the most helpful tool, I think, that I've learned in my life. And so on the right-hand side, I want to show you a little bit of what I meant when I said to stay organized. What you see here is an example folder of a research project, what I would use usually. So in white, you see the different files, and the blue parts are the different folders. And you see that I have, for example, a make file in the main folder, which is really the code to use make. And then I have the different sections of the paper in there. You could also have like one file with the entire paper, of course. I just like to have it separately. I don't know why. And then I have usually a folder called journal correspondence, where I keep all the peer reviews and all my responses to peer reviews. And then, of course, what's most important to this talk, the analysis folder. And there I keep the code files, so the code scripts, and the data. And you might notice that there's two data folders. There's one that's called data, or sometimes I also call it data clean. And then there's one called data original or data raw sometimes. And I keep those two separately because I want to have one folder where I keep the raw data that I never touch again. And to me, this is really important, that the raw data stays in its original form, and then the clean data can change over time. And then I usually also have a folder called bases or functions, where I keep all the more complex functionality that I write in code in R. So this is more or less how I organize all of my research projects. Now, I mentioned a couple of tools, and I want to show you a little bit of what this looks like in practice. So this is what you see here is an example from an actual paper that I wrote. It's a paper about an R package that I wrote. So it's maybe a little different than other papers I would write when I'm doing health research, right? So here on the left-hand side in gray and green, you see the text file, what it looks like for me when I create it. And on the right-hand side, you can see what it looks like when you render it to, in this case, an HTML file, so a website, or you can also generate PDFs, Word documents out of this, what you see here on the left. And the tool to do that is called Knitr, and it's a combination of LaTeX and R. And there's something similar for Markdown in R as well, in case that is easier for you. So here on the left-hand side in green, you see the parts that's code. And in gray is the parts that's just normal text. And if you go to the right-hand side, you see how this turns out when I render it to into the real paper that I want to have in the end. And it looks kind of nice. I have a figure caption, and yeah, it just works really well for me. And it makes my work more reproducible and easier to make it reproducible, because I just write the paper and the code parts are just included in the paper text. Now, another tool that I mentioned was Make, and that was the tool to glue the different parts of the analysis pipeline together. And how does Make work? It's really just essentially telling, it's a recipe for saying, okay, what is the thing that I want to create? And in this example, I want to create a PDF file, so the paper, for example. And what are the files that this target depends on? So this might be different parts of the text, for example. And then in orange below, you see the command that I need to run in order to get the target from the dependent files. And I want to show you an example again of this paper that I showed you before. And I acknowledge that this is a very simple make file. Most of my make files for other projects are more complicated. In this case, it's so simple because I already have all the code and the data included in the R package in this case. So I don't have to have a script for loading data, cleaning data, and so on, which I would usually have additionally here. In this case, I just want to create the PDF which is my paper from the file that I showed you before that combines the text and the code, which is a .rnw file. And here you see that I have 3 different targets, which are the things that are shown in yellow. So first my target is the text file, and I want to create it from this Knitr file that I showed you. And then below you see the code that's needed to create that. And then for creating the PDF file, I have two files that depend on this. So if I change those, if I change either the text file or I change the bib file, which is the file that contains all the references, then I need to run the code in orange that's below the yellow part. And then there's this specific tools that we can use in Make to make our code a little bit more easily usable, because usually what you then say to like the pushing button part that I mentioned before is I have to say make, and then I say man_model for you.pdf. And in order to not have to write such a long thing, I can just write make all if I have something like here on the bottom. I hope that makes sense for people, and I'm happy to explain it further if there's open questions on this later in the Q&A. So I talked a lot about like how reproducible analysis pipelines could work, examples of how I do it personally, but you might want to dive deeper into this now and might want to learn more about it. And there's one book that I really recommend checking out, and it's called The Turing Way. And it's a handbook to reproducible, ethical, and collaborative data science. And in all of my trainings and also for my own work, this is the book that I use as a basis because it contains all of the needed information. It's written in a way that you can understand, and it's also very practical and hands-on. So this is something that I can really recommend checking out if you're interested in making your own work reproducible as well. And with that, I want to say thank you and hand over to Rosie for the Q&A session.
Thanks very much, Heidi. That was really interesting. We do have a few questions that have come through. So first of all, are there any advantages of using Make over the targets package?
So yeah, thanks for that question. I showed like one thing that you could use, and there's lots of other tools out there that are similar to Make. There's the targets package, there's Snake Make, there's all kinds of different things. I like using Make for the simple reason that it's been around for such a long time. And I know, and I just believe truly that it's going to be around for a long time still. But that's really the only reason why I use it. And if you're already worked with something, you like sticking to it. So I hope that makes sense to the person who asked the question.
Thanks. One more question in the Q&A, and I think there might be one or two in the chat as well. What advice would you give someone from a biological background learning R or Python for the first time?
Oh, wow. Good question. So I've been using R since 2009 now. And for me, what helped me really keep going and sticking with it and learning it further was doing little projects. And so if you're interested in learning programming in general, it's always good to have a fun project where you, or just like your actual work might work as well, I guess, where you can practice it, where you can implement everything that you learn. For learning, there's lots and lots of free tutorials, but also like you can go on DataCamp or other sites where you can pay for it. There's all kinds of like learning opportunities. You can check out maybe also data carpentries, which is something I can really recommend if you want to learn in a group on site. So I guess that would be my recommendation. Also get involved in the community and ask people for support there. Twitter is usually very helpful. So in our community, we use the hashtag #RStats. And there you usually get an answer if you ask a question that makes sense.
Thanks, Heidi. There is another question in the Q&A, which is, do you also keep questionnaire or a tool in Make, and how do you do this?
So these tools that I showed today work really well with files and programs that you can run with some sort of command in the command line. Not sure if, so not all tools work that way, and I'm not sure what you would do in terms of a questionnaire. I think usually questionnaires are created. So I'm not an expert on this, but I think usually they're created in some sort of web platform. So this might not be what I would include in the reproducible analysis pipeline, but this is rather something that goes before that. If you can make that reproducible as well, that's obviously really cool, but I'm really not an expert in this. I'm sorry.
Thanks very much. I think there's also one in the chat, which I'll ask you to look at, Heidi, if I may. It's from Jackie, and it's one of the most recent ones.
Yeah, okay, so looks like a very useful catalog of assets. Can you add descriptions of, for example, of clean data.r, etc.? Also, are you hoping to create standards using this approach? So the slide that I showed with all of the files and folders that I usually have as part of a research project, that was essentially just an example of what it could look like, right? So for example, this clean underscore data.r is an R file, so an R script that takes the raw data and cleans it into a version that I actually want to work with. Because usually we have some, I don't know, things that we have to figure out, like how do we want to encode something to be able to work with it in the analysis and just make it nicer for example, figures in the end, so that the words are understandable for people and not only for computers. And those are the different things that I showed, but it's really just an example. In your case, it might even be separate files that where you do data cleaning of different data sets or what have you. I don't know if that answers the question. Okay, she's writing thank you, so I guess that's okay.
There's another question in the chat, Heidi, from Katrina, regarding questionnaire or discussion document. Can you still use Git for version control or just for code?
So you can use Git for version controlling anything that's text, or that's what it's good at least. So you can use version control or Git for other things like images and stuff as well, but that's not real. There it's not really as good, right? Because what we can do with Git is we can really look at the different changes in a text. And if it's an image, then it's just a new image that's on top of the old image. But with the text, I can really see which blocks have been changed, by whom, when, and why, which makes it really useful for these things that are, text-based. So anything that's text-based can really be used in version control with Git. And maybe to avoid like misunderstandings, when I say text, it means that I can open it with any text editor. So for example, Word files are not text in this sense, because I can only open it with with an Office toolkit and not with a regular text editor. I hope that makes sense.
Thanks. Which frameworks or languages that biologists new to coding might benefit from focusing on learning?
Can you ask again?
Sure. Can you think of any frameworks or languages that biologists new to coding would benefit from focusing on learning, for example, Python?
Yeah, so that's a very broad question. I think, first of all, don't learn it all at once. These tools usually have some kind of a learning curve. And if you try too many things at once, then you're just going to be overwhelmed and drop it all. So I would say do one thing at a time. So I'm a huge fan of R. I think R has the broadest, most widely applicable usage for, in particular, health research and biology, because there's different R packages for all kinds of different statistical analysis that you would want to do. So I would recommend learning that, but Python is really super good as well. So one of the two, I think, is the most standard tools that you would want to learn if you want to get into more reproducible workflows.
Thanks so much, Heidi. That was great. And we are out of time. So I just want to thank you, Ruth and Heidi, so much for joining us today and talking to us. Apologies for the technical glitches at the beginning, but I think, Heidi, your talk was really, really valuable. And I hope that everyone got something from it. So we'll wrap it up there. There will be a feedback survey coming out to you, so we'd really appreciate it if you would fill that out. And just to say thank you so much again, Heidi and Ruth, and have a great day, everyone.
Thank you for having us.
Thank you so much.
Bye.